Hello, my dear students. Today we can do the second part of defects in solid. That is, first class we discussed stoichiometric defects such as Frenkel defect, Schottky defect, right? So today we can discuss non-stoichiometric defects. Fine. So the heading you can make as non-stoichiometric metric defects. Okay, it's metric. Fine. Non-stoichiometric defects. So what is the meaning? That is, this defect will affect the stoichiometry. That is, there will be a ratio of anion and cation, right? So due to the defect, that ratio will change. That is, it is affecting the stoichiometry. So that is why it is non-stoichiometric defects it is called. It can be classified as mainly metal excess defect is there, okay? Metal excess defect, first type. Then second type it is metal deficiency. Metal deficiency, fine. Okay, so first we will discuss what is metal excess defect. From the word meaning, metal excess means one metal is extra in the crystal. So here it is due to two things. It can be again classified as two. One, it is by anion vacancy. First one. Second one, due to extra cation. These are again classified as like this. By anion vacancy, that is, a negative charge is less, right? Due to extra cation, one positive charge is more. So here also first we can discuss what is by anion vacancy. How? So we have taken a crystal lattice. Here you can take a crystal lattice of NaCl. So here plus minus plus minus. It will be equally distributed, right? Minus plus minus plus, then plus minus plus minus. Anion and cation, where minus is chlorine, plus is sodium. Okay, this is an NaCl crystal. Okay, this is an NaCl crystal we are taking as an example to explain anion vacancy. Okay, so here it is simple. You have taken an NaCl crystal. We are heating this NaCl crystal in the presence of sodium vapor. So what happens? Sodium will deposit on this crystal on the outer layer. So here sodium will leave one electron and form as Na plus ion. So it is depositing in the form of Na plus ions on the surface. Okay. So due to this Na plus in the outside, one chlorine will go and attach to Cl and it will form NaCl. So there is a deficiency here, right? There is a vacancy of anion, negative charge, right? So in order to make it electrical neutrality, this one electron that is released by this Na, it will come and occupy in the place of that vacant place. Okay. Now electrically it is balanced, but there is a deficiency of chlorine. That is, there is a vacancy of anion here. That is why it is known as by anion vacancy. The deficiency is occurred here. And one important point is here. Here this electron is unpaired electrons which occupy in the anion vacancy. It is known as what? F center. It is called F center, and it determines the color of the whole crystal. So NaCl crystal is colorless. When we heat in the presence of sodium vapor, it becomes yellow because of this F center. That is why it is also known as color center. Okay, that point is really important. Okay, hope it is clear. Now we will discuss due to extra cation. Okay, so next metal excess defect is what? Due to extra cation, how it has come. Here we are taking an example ZnO. Okay, so we are taking a crystal lattice of ZnO. ZnO. And we can represent small circle as Zn and big circle as oxygen. Okay, like that it is a crystal lattice of ZnO. You can arrange like this. Okay, fine. So this is a ZnO crystal. So here Zn has 2 plus charge and oxygen has 2 minus, right? We are heating again this crystal lattice. So what happens? An oxygen, single oxygen comes out from this crystal lattice. That is as a single O. For that you can represent half O2, right? A single O. And it comes out from the crystal leaving these 2 electrons inside it. Okay, so here one oxygen has, this is an oxygen site, right, lattice site. In that place it has left the 2 electrons there and a single oxygen has came out. Okay, and what happens? There is a deficiency, not deficiency, there is an extra Zn, right? For Zn has gone, but Zn2 plus is extra there, right? That is 2 plus. Extra cation is there, okay? Okay, so the Zn2 plus is extra. It will go and occupy. So let this be the Zn2 plus. It will leave from its lattice site and occupy in any of the interstitial sites. Similarly, these 2 electrons also occupy in other interstitial sites near to it. It will not be in its own lattice site. It will occupy, go here and there in the interstitial site. Okay. So here an extra cation deficiency is there, right? That is 2 plus, that is cation plus charge. And here also this color of the crystal lattice is because of this extra 2 electrons. This is the reason for the color of the crystal lattice. Okay, you can note down as reason for color. Here also that extra left electrons, that is the reason for the color of this crystal lattice. Okay, so after this deficiency there is a change in the molecular formula, right? Actually it was ZnO. Now what happens? If oxygen was X number, one extra will be Zn, right? Oxygen has came out from the crystal lattice after heating, so cation is extra, that is one metal is extra here. That is why metal excess defect. That is, if X is O, one extra will be Zn will be there. So this will be the molecular formula of this defect of after occurring the defect. Fine. So it is clear, I think, by anion vacancy and due to extra cation. You can quote an example and study, then it will be very easy to remember. Fine. Now we can discuss metal deficiency defect. Fine. Okay students, so next metal deficiency defect. That means a metal is less, otherwise a cation is less. So here we can take an example FeO. FeO, if this is a crystal, okay, we have FeO crystal, and Fe has 2 plus charge, it has 2 minus. 2 plus 2 minus. 2 plus 2 minus, 2 plus 2 minus. Okay. Now what is the total charge here? 4 Fe, that is 8 plus charge, right? Here 8 minus. So before occurring the defect, it is electrically neutrality is the same, ratio of anion cation is the, that is before defect. Okay. Now if we remove this 3 Fe2 plus from this crystal and we have added 2 Fe3 plus crystal, fine. Now if we add the charges 6 plus 2 8, here also there is no change, 8 minus. Now electrically it is neutrality is the same charge, but there is a deficiency of one ion, right? Fe is 1, it is less compared to there is 4O, there is 3 Fe. That is a metal iron is, that is a metal, it is deficient. Such defects are called metal deficiency defect. It occurs mainly in transition elements, that you can remember, okay. In transition elements we can see such type of defects, metal deficiency defect. Clear? So the last one more defect is the, which was we, in that figure we have one in one side, we have marked impurity defect. That also we can discuss. Last and final defect in defects in solid, that is impurity defect. Impurity defect means one impurity will be added to a crystal. That is, if the same case we are taking NaCl crystal, okay, there is Na plus is the Cl minus, Na plus Cl minus Na, like this crystal lattice of NaCl, okay. In this case, in the place of 2 Na plus has gone, in that place one impurity Sr2 plus has added. So in the place of Na, one impurity is added, right? Such defects are called impurity defects. It's easy, right? Fine. Yeah, so that's all about the defects in solid. Now the flow chart is complete. I think we started from last class, we discussed the stoichiometric part. Today we discuss the non-stoichiometric part. Full part is important, especially short key Frankel, then anion vacancy due to extra cation. Such type questions can be asked from that part. Okay, so the full flowchart you complete and study. Okay, next class we can start a new topic in the same chapter. Okay, till then, bye.